You are highly welcome, sir. Hello, sir. Good evening, our teachers, colleagues and colleagues. Welcome to the last week of ARD UDUTH Research Methodology Workshop. Today we are in day 2. I will continue from where we stopped yesterday on the topic data analysis, descriptive and inferential statistics. We'll see how to create tables and charts, how to defend a proposal or dissertation. Thank you so much for being with us this long. I want to use this opportunity to once again welcome our teacher, Dr. Malami Bello, who has been with us for this long time. Thank you so much, sir, for accepting to put us through. Thank you for joining. You are highly welcome, sir.
Yes, thank you very much, Dr. Mustafa. And thank you for all being with us. So today we are going to continue where we stopped yesterday. Let me share my screen. Okay. So yesterday we were talking about the data organization, data entry, data cleaning, and data transformation. So today we are going to continue from data. I think we stopped at data transformation. We have done data entry, data cleaning, then now data transformation. So we started by creating a new variable from an existing variable yesterday, where we created age group from age that was collected from the field. So another form of data transformation is when you want to develop another variable, create a new variable from an existing variable. For example, BMI, you want to create BMI from weight and height. You have collected your data on in weight and height. So when you come for analysis, you have to create a new variable, which is BMI, using these two variables. So how do you go about it? So let's do it. You see, as I have said yesterday, you must, before you even start this analysis, you have to do all these things, that data cleaning, data transformation. This transformation is very, very important because most of your objectives could not be answered without transforming your data. So you have to look at the objectives that you have. And then you now think of how am I going to transform this in order to achieve my objectives? For example, now you want to know the level of practice of something, maybe practice of infection prevention and control. So this level of practice, you cannot take it direct from the field. You have to now, it is during the analysis that you now find out what is the level, if their level of practice good, or if their level of practice appropriate or not appropriate. Because there are different questions that you will ask that will ask about the practice. Maybe you have 10 questions to ask as questions for practice. So you cannot, if you take this data from the field, you cannot know whether they have good practice or appropriate practice with just seeing the question. You have to mark the question, award the mark. You have to assign a point value for each mark, for each question. For example, it may be each question, each correct practice will make someone award, will be, and everybody with a correct response will be awarded maybe 1 mark, then wrong response will be awarded 0 mark, something like that. So after giving mark, assigning mark to each and every questions, then you now add up all the questions to find out what is the total marks scored by each and every individual. So this total marks, you now use it also to convert it into percentages. When you convert it into percentages, then this proportion now that you have converted, it is the one that you categorize now into whether appropriate practice, inappropriate practice, or good practice or wrong practice. So all these things can be done using transformation processes. So this is the transformation. In transformation, you can transform your data to suit any of the objectives that you have. So let's see how to now go about converting or developing, creating BMI from weight and height that are being collected from the field. So first of all, when you open your data, you now go to transform. When you go to transform, I hope you are seeing my screen.
Yes, sir. Yes, sir. Yes, sir.
Yes,
Okay.
we are seeing you, sir.
Yes, sir, we are seeing it.
Yes. So you go to transform, then number 1 option there, compute variable. So you see the difference between this transformation and the transformation we have done yesterday. In yesterday's transformation, where we want to create an edge group from existing variable, which is edge. So you see, it's the edge. This is the variable that we want to create another variable from it. So in that one, we use record into different variable. Record into different variable. But if you want to create an entirely new variable from an existing variable, then you use compute variable. So when you click on transformation, for this one, we click on compute variable. So when you click on compute variable, you will see, this is what you will see. Okay. I can hide this. I don't know. Okay, now, when you click on compute variable, you will see this dialog box. So the first part of it on the left side is target variable, then numeric expression. Then this box contains all your variables that you have. Then here you have a calculator. This is your calculator. You use it to make any calculation from your different variables. So now we have, in our data, we have weight and height. We collected weight in form of weight in kilogram in kg, while height in meter. But you know, BMI is equal to weight in kilogram over height in meter squared. So you have to now create a new variable, which is height in meter squared, because we don't have it. From the field, we only collected height in meters. We have not converted it to meter square. It is now from this place that you now create a new variable called height in meter square. Then you use weight in kilogram divided by height in meter square to calculate your own BMI. So let's start with calculating, defining height in meter square. So when you click on transform, create new variable, then it will take you to this box where you have a target variable and numeric expression. So our target variable now is what? Height in meter squared. So you write it, height in meter squared. So, you know, as I have said yesterday, in writing any name, there should be no space in between words. So if you are writing a name, either the name of your target variable, don't leave any space in between. Just merge all the words together and make sure you summarize. If it is long, you just make a quick summary that you can understand. So my target variable now is height in meter square. So you see equal sign in between these two boxes. Target variable and numeric expression, you see equal sign. It means height in meter square is equal to what? So you write your formula in the numeric expression here. So how do you write it? So we say height in meter square is equal to height in meter times height in meter, because we have to, if you want to take a square of something, just that number times that number is a square of that number. So here we want to say height in meter times height in meter. It will give us height in meter square. So let's now check in our data, where is height? So I now start scrolling down. You see my weight is here, number 27. Then my height is here. Height in meter is here. So I will now click on it to highlight it. When it is highlighted, then I click on this arrow to put it in the box, inside this box, this numeric expression. So here you see height in meter square now is equal to height, then times. You now come to your calculator here. This star is your terms. You have plus, you have minus, you have times, you have division. So whatever you want to do, if you want to add some variables, or you want to subtract some variables, or you want to divide some variables, or you want to multiply some variables, this is what you will be using as your calculator. So here I will say times. So you see height times height again. I'll click on height again and take it there. So you see height in meter square is equal to height times height. So this is okay for me. Then I will click OK. When you write the full formula that you want, then the next thing is just click on OK. So as you click OK, your new variable is being created. So you can go there and see it as the final or at the last variable in your weather data view or variable view. So if you go to the last variable there, you will see the new variable that we have created. You see it. The last variable here is height in meter square. So this height in meter square, it is the one that will now be used to calculate our BMI using weight and height. So you know weight, BMI is equal to weight in kilogram divided by height in meter square. So we have now created height in meter square. The next thing is to divide our weight by height in meter square. So how do we go about? You go back to transform, click on transform, click on compute variable again. You see the formula we have used initially is already there, so we don't need it now. We now reset. We click on reset. Down the box, you see reset. You see OK, paste, reset, cancel, help. So click on reset. It will reset everything. so that it refreshes the box, and you are now free to write your new variable that you want to create. So now our new variable we want to create is what? BMI. So we say BMI, or body mass index. BMI, body mass index. So now you see BMI is equal to what? Numeric expression. You now come and express what you want, what you want to put as your BMI. So you say BMI is equal to what? Weight. Let's check for weight in our variables. See, this is the weight now. Number 27, question 27 is weight. So you click on it and you take it in the box. So you see now weight divide by, so you see in your calculator the division, this is the division sign. You now click on it. Weight divide by what? Height in meters square, which is our last variable that we have created earlier. So you now click on it and take it into the box. So you see we have written our now formula. The body mass index is equal to weight divided by height in meters square. When you are ready, you put your variables that you think they are okay for your formula. Then you now click on what? You click on OK. So we click OK. When you click OK, it has created our, so when you come back, you see our body mass index is being created now. So you see it. This is the body mass index. So now, this body mass index, if you want to categorize it, whether into overweight, underweight, obesity, underweight, or overweight, or obesity. So this is what you use. Then you use record into different variables as we used for age grouping yesterday. I don't need to go back to it since we have done it yesterday. So you just use that. You now find out the minimum BMI here and then the maximum BMI, so that you know how to make a category to categorize your BMI into underweight, normal, overweight, obesity. So that is all for this type of transformation. You can also want to maybe transform your data by creating a variable from different, maybe you want to add some variables, you want to add them up to have a sum of that those variables, maybe for creating a total score for something. If you want to find a total score, just go to transform, create variable, then add all the questions that you want to add together, then click OK. It will give you the sum total of all the variables that you want to add. So this is data transformation. Now, when you are through with your transformation, so now you want to start the analysis proper. So analysis is categorized into two. You have descriptive analysis and inferential analysis. Descriptive analysis is just the analysis of the variables. You want to know if they are categorical variables, you just want to know the frequency and percentages of those variables. So it's also dependent on your what? Objectives. Some objectives only require frequency and percentage. If they are numeric variables or continuous variable, you just need mean and standard deviation. So these are categorical or descriptive. These are descriptive statistics, just to find either a frequency and percentages or mean and standard deviations. So how do you do it? Let's start. If you want, let's start with categorical. Categorical variables. or descriptive statistics, descriptive analysis. In this data, so in this data, you see, let me go to the social demographics. Yeah. So I have age category here. I have highlighted it, you will see it. I have sex. I have okay. So let's say age category and sex. These are the two. Okay, I have tribe here. Tribe, religion, marital status. So they are all categorical variables. And let's say I want to know the frequency and percentages of each and every one of these variables. How am I going to do it? You can use different ways. You can go to analyze, number one. For example, you go to analyze, you see descriptive statistics. Go to descriptive statistics, then frequencies, number one. That is option number one. Analyze descriptive statistics, then frequencies. You click on frequencies. So when you click on frequencies, this is where you will see all your variables. So here you can include all the variables that you want to know their frequency and percentages. You can put them together. You can put them at once. So just highlight each variable that you want, highlight it and take it to this box, to the variable box. You see, I've taken age category, then sex, I've taken it. Then here I have tribe, I have religion, taking it, marital status, taking it, a highest level of education, I'm taking it. So you see, I have taken all the variables I want to include in this analysis in my box, that is variable box. Once you put all the variables that you want, next thing is to do what? Just click on OK. So you click on OK. When you click OK, you will see your result. This is my result. So this is my result. This table number one is just a summary of the variables that we have included in the analysis. You see, it has shown that we have included age cuts, which the valid number of participants there is 118, and we have 0 missing value. So you can see if you have any missing value, once you do your descriptive statistic, you can see a variable that you have a missing value there. So you can, once you see a missing value from any variable, you can go and fill it there. So now you see I don't have any missing value from each and every variable.
We are not seeing, sir.
You are not seeing.
Yes, sir.
Okay. Let me reshare. Are you seeing it now?
Yes, sir. We can see now.
Okay. So this is the output. When I click OK, this is output. This is my output. That is my result. So from the table one, you see, table one is statistic. It gives you a summary of all the variables that you have included in the analysis. So in the table, you see valid and missing. Valid is the total number of all the sample size you have included. Then missing is when if there is any respondent whose data is missing in any of the variable, it will show here. So you now see that in all the variables, I have 118 participants and zero missing values. So now let's go to the next one. The next one is what? Age category. This is frequency table. Age category, this is my age category. These are the age categories that are there: 18 to 44, 45 to 64, then 65 and above. You see frequency, percent, valid percent, and cumulative frequency. So here you only need frequency and valid percent. Frequency and valid percent. So the frequency 18 to 44, they are 29 in number, and they constitute what? 24.6% of the total respondent from this research. Then respondent that age 45 to 64 years, they are 79, which constituted 66.9%. While those that are 65 and above, they are only 10 in number, which constituted 8.5%. So you see, you have your results in terms of frequency and percentages. So all the variables that you have included, you go down, you scroll down and extract your results from the tables made by the SPSS. So in the SPSS table for frequency, you only need, I told you, you only need frequency and then valid percent. Why do you need only valid percent, not percent? Valid percent, if you have any missing value, it will not include the missing value in valid percent, but it will include even the missing value in the percent. So that is why you need you are advised to use valid percent in your percentages that you are going to report in your tables. So this is frequency. This is descriptive analysis for what? For categorical variables. Then what of for continuous variables? For continuous variable, you need mean and standard deviation for all of them. So anyone that is being taken in number, like for example, height on its own, weight on its own, age, row age as per row age, not age category. So all this one, you now analyze them using what? Mean and standard deviation. So you will find mean age, mean weight, mean height. So how do you go about it? You still do the same thing, analyze, click on analyze, descriptive statistics. Then here you click on descriptives, not frequencies. The second option, which is descriptives, you now click on it. When you click on it, you now select all the variables you want to include in this one. So here we select row age. Row age is here.
Sorry, sir. I think, sir, maybe you have to still reshare. We are still on the other one.
Okay.
It's still showing those frequency table.
Yeah. So when you want to analyze your continuous variable, that is descriptive analysis for continuous variables, as we have said, like age, weight, height. Age, which is not in category, age in number. So you click on analyze, descriptive statistics, then descriptives. So you click on descriptives. So from here, you select all the variables you want to include. I will now select age, which is in number here. I'll go and select weight. You see, weight is here. I select it. Height in meter is here. I select it. Systolic BP is here. I select it. Diastolic BP, I select it. So you see all these ones, they are taken in quantity. They are taken as continuous variables. So when you finish entering all of them, you click on what? OK. So as you click on OK, you will now see your results. Let me share again. So you see your result. This is our results for this one. So you see the last table down, which is descriptives. Each one, it has what? N, which is total number of participants, total number of our sample size, then minimum, maximum, mean, standard deviation. So these are the, this is the results for continuous variables. But here you need only mean and standard deviation. So our mean age here is 51.66 plus or minus our standard deviation, which is 8.897. So our weight, the mean weight was what? 73.22 plus or minus 15.435. That is how you now now use all these values, your results, and put it in the table. Put all your create them in the table. So this is the descriptive statistic or descriptive analysis. Descriptive analysis is only this, whether it's frequency and percentages or is mean and standard deviation or median and mode and range. I mean, so if you want to have, maybe you want to find median, maybe your data is not normally distributed, you want to know the median or range, this is what you do. You do the same thing, analyze, descriptive, statistics, descriptives, descriptive. Then in the options, you click on options. Here you have different options. You have standard deviation, minimum, maximum, range. You see range. Where is median? Okay. So I didn't see median here. So, but there is a range. But still, if you want to do median, you can highlight your, highlight all the values here. That is another method of doing descriptive statistics or descriptive analysis. For example, let's say I want to know the mean, median, and mode of the age. I just highlight age like this, and you see this signs. There is sign to run descriptive statistic. This sign, run descriptive statistic. Are you seeing it?
No, sir.
Okay, okay. So you see, at the top end of the software of the SPSS, you see different signs there. there is this sign, this one, which is open data. This one, save this document, print, recall recently used dialog, undo, redo, go to case, go to variable, then variables, then run descriptive statistics. Once you highlight any variable that you want to run descriptive statistic, you can, whether it is continuous, whether it is categorical, you just highlight it. Once you highlight it, click on this sign, run descriptive statistic. It will run your descriptive statistic without going to analyze descriptive and other things. Just highlight it and click on this sign. It will run your descriptive statistic. So let me use it. Let me say, I will now create or analyze this age in years. So just highlight it and then click on this. As I click on it, you will see my result here. Let me reshare. So this is my result, the last table. Age in years. You see, we have mean, we have median, we have standard deviation, range, minimum, maximum. So here you can now take all what you want. If you want to use mean and standard deviation, there is mean and standard deviation. If you want median and range, there is median and range. If you want minimum and maximum, there is minimum and maximum. So whatever you want to present in your table, you can take it using this brief or this descriptive statistic. Even if it is categorical variable, you just highlight the variable. Once you highlight it, then click on this sign, which is descriptive, run descriptive statistics. So this is all about descriptive statistics. Then inferential statistics or inferential analysis. So inferential analysis, in inferential analysis here, it uses hypothesis testing. Hypothesis testing. You already have your hypothesis from your objectives. So now in your analysis, method of data analysis in the proposal, you said objective one, maybe chi-square test will be used to do this, to find association between this and that. So this is where your analysis plan will help you. So you say for each objective, you have to, from the proposal level, you have to identify, you have to know the type of test statistic that you are going to use in assessing that objective. So now if you know, just apply it only, just apply it. But if you don't know, you have to now find out which test am I going to use now to get this my objective, to answer this my objective. Which test am I going to use to answer this and answer that? So now, let me just briefly take us into hypothesis testing and see the different tests that we can apply for different statistics briefly. So I will share, okay. I'll share another, yeah. So this is my presentation on hypothesis testing or statistical inference or inferential statistics. So inferential statistic refers to the procedure by which we reach a conclusion about a population on the basis of information contained in a sample drawn from that population. there are two methods of statistical inference. We have estimation and we have hypothesis testing. So estimation is only when you use mean and standard deviation. You estimate the parameter of a given population using a sample. Maybe you now take a sample and find the edge of that sample. So when you find the edge of the sample, it's like you are estimating the edge of the entire population from that sample. That is estimation. So now the next thing is hypothesis testing. This is where I want to discuss what I want to discuss. So we have discussed all these things from our earlier presentations. That is hypothesis. What is hypothesis? What are the types of hypothesis? We have null hypothesis and alternate hypothesis, one-tail, two-tail hypothesis. So what I want to discuss briefly now is steps in hypothesis testing. What are the different steps that are involved in hypothesis testing? So there are 4 steps in hypothesis testing. Step number 1 is what? You have to state your null hypothesis. So this, you must have done it from your proposal. In your proposal, you must have stated all your null hypothesis and alternate hypothesis. So when you state your hypothesis, that is the alternate hypothesis and null hypothesis, then now you now set criteria for a decision. That is, you set the level of significance that you are going to use, which we usually use 0.05 as our level of significance. This means that any result that is less than 0.05 will reject, or we are going to reject the null hypothesis. While if we have results with a p-value of more than 0.05, then we are going to fail to reject the null hypothesis. So this is the criteria for decision. Then step 3 is choosing an appropriate test statistic. This is what I want us to make to be more attentive. So how to choose appropriate statistic you are going to use in your data analysis. So the choice of appropriate statistic depends on different things. One, type of data. Is your data numerical or categorical data? If numerical data, if you are dealing with numerical data, that is continuous data, these are the possible tests that you are going to use. One, t-test. T-test can be independent sample t-test. It can be paired t-test. Then you have z-test. We have f-test, which is also called analysis of variance or ANOVA. We have correlation. We have Mann-Whitney U-test. We have Wilcoxon-Sain rank test. And we have Kroskal-Wallis and Friedman's test. These tests, they are only done for data that is collected in number. That is numerical data or continuous data. While for categorical data, the possible test that you are going to do is one, chi-square, Fisher exact, or McNemar's test. All these tests they are dependent on the objectives of the study. Then you can also look at distribution of the data. Is the data normally or not normally distributed in choosing the right test statistic to do? You may, after looking at the type of the data, you can also look at the distribution of your data. Is your data normally distributed or not normally distributed? And how do you know whether your data is normally or not normally distributed? Number one, if you have enough sample size, a large sample size, once you have a large sample size, you just assume that your data is normally distributed. And the large sample size start with 50. If your sample size is 50 and above, so it's likely that your data is normally distributed. But in case you still want to do, you still want to find out whether your data is normally or not normally distributed, you can calculate the mean, median, and mode from that data. Once you calculate mean, median, and mode, if the data is normally distributed, mean will be equal to median and will be equal to mode. So it means your mean, median, and mode, they are almost similar, if not the same. They are the same or almost similar. So once you calculate mean, median, and mode, and you find out they are all similar or they are the same, it means that data is normally distributed. But if they are not the same or they are not similar, they have a wide difference in between them. So it means the data is not normally distributed. But you can still apply the central limit theorem, which says that once the data is large enough, that data is assumed to be normally distributed. So you just go ahead with tests that are tests of normally distributed data, which are parametric tests. So if the data is normally distributed, you are going to use parametric test. While data that is not normally distributed, you use non-parametric test. So another quality you are going to consider in selecting the type of test statistic is number of the population sample. How many samples do you have in this research? Is it only one sample? Or you have two samples, maybe research group and control group. So in this case, you have two samples. But if you have two samples or one sample, each one is dependent on, there are different tests that you will do that you select for each type of statistic. So if your data is only one sample, you want to compare only one sample. So you are going to use what? One sample t-test or z-test. If you are comparing two samples, you can use independent sample t-test, paired t-test, Mann-Whitney U-test, or Wilcoxon-Sain rank test. If your data is having 3 or more samples, you are going to use ANOVA, that is F-test, or repeated major ANOVA, or Wilcoxon-Sain rank test, Kruskal-Wallis test, or Friedman's test. So these are the possible tests that you are going to use in case you want to compare 3 or more samples or 3 or more categories. Then another parameter that you are going to consider in selecting your variable or your test statistic is what? Relativeness of the samples. Are these samples related or not related? Are they related or they are independent? What are the related samples and what are the...
Yeah.
Yes, what do you say?
What?
Okay. So please, someone is has not muted himself. Please mute yourself. Okay. So you can use whether you can now find out whether your samples or your samples or your groups are related or not related. What are related samples and what are the independent samples? The dependent samples or the independent samples are the two samples that are independent of each other. Maybe group 1 and group 2. You have two groups and you want to analyze them. You want to analyze them and you want to know whether there is an association between this, whether there is a difference between this group and the other group. For example, in case control, whether cases are they different from control or control are they different from the cases. So this one, they are independent. no one is related with the other. But the related samples, when you have, for example, one sample that you have taken the data from that sample at 2 or more different times. For example, you say, I have one sample now. I take data at baseline. Then I give them training. I train them after the baseline data. Then after the training, I take another data. So you see, I have 2 different data from one sample. So this is like a related, they are related samples. So this one, the type of test statistics that you are going to choose will be different from the one you are going to choose if they are independent. Another related samples is when you give, you want to find the relationship between, or whether a drug, a particular drug can cure a particular disease. So for this group, you give them, you give each of the group at the baseline, you give them the drug and the placebo. Why? After sometimes you now find out which of the group is having more effects of the drug than the other. So you see, they are related samples. That is before and after, or related samples, one sample at 2 or more different points in time. So in this case, you are going to use what? If your data is, if your samples are not related or independent, you may select independent sample t-test, z-test, ANOVA, chi-square, Fisher-Exact, Mann-Whitney test, Kruskal-Wallis test. But if your samples are related, so you can select either paired t-test or repeated major ANOVA, McNemar's test, Wilcoxon-Sign rank test. These are the possible tests that you can select for samples that are related. Then, okay, next is sorry, the system is hooking. Yeah. So the next parameter that you now you want to consider for selecting this particular test is what? If your that is study objectives. If your study objective or questions to be answered it can be to find an association or relationship or difference between means or difference between medians. So in that case, to find association, you can use chi-square, Fisher-Exact, or McNemar's test. To find relationship, you can use Pearson's or Spearman's correlation. To find difference between means, you can use t-test, z-test, or ANOVA. To find difference between medians, you can use Mann-Whitney test, Wilcoxon-Sign rank test, Kruskal-Wallis test, or Friedman's test. So now the next step, when you select your appropriate test statistic, you now run it in the SPSS. Then the final step for hypothesis testing is to make decision. How to make decision? You either reject the null hypothesis or you fail to reject the null hypothesis. So now let's go back to our SPSS or our test statistic and see how to do some of this, how to run some of this statistic in SPSS. So I will now start with parametric test. So let's start with parametric test. Okay, parametric tests are statistical tests that assume the data follows a specific distribution, typically a normal distribution. These tests are used when certain assumptions about parameters of the population distribution are met. So what are the assumptions for parametric tests? We have earlier said that parametric tests are those tests that can be done when the data is normally distributed. So if the data is not normally distributed, you will do non-parametric tests. So let's start with parametric tests. These are the assumptions for parametric tests. For you to select any of the parametric tests, you have to look at this assumption first. Number one, the sample is randomly drawn from the target population. So random selection of the sample at the beginning. Then number two, data is continuous. Your data is a continuous variable for you to do assumption parametric test. That is, your data must be in continuous variables like age, like mean, weight, like height, blood pressure, whatever that is taken in continuous variables. These are the tests, or these are the type of data that you are going to use parametric test for. So another assumption is what? Data is normally distributed. As we have said earlier, how to check for data that is normally distributed. I said we can calculate mean, median, and mode. If the mean, median, and mode are all the same or similar, then data is normally distributed. We can also calculate we can also run this Kolmogorov-Smirnov test in SPSS. Then another assumption for parametric test is what? Homogeneity of variance. This, I will not bother you with this. So let's start with common parametric test. Number one is one sample t-test. The one sample t-test compares the sample mean to a known value. Then independent sample t-test. This compare mean between two independent variables. Then paired sample t-test. Paired sample t-test compares means from the same group at different times, as I have explained earlier. Number two is analysis of variance. This is also one of the parametric tests. It's used to compare means among 3 or more groups. We have different types of analysis of variance. One is one-way ANOVA. If we have one independent variable, we also have two-way ANOVA for two independent variables, and then we have repeated major ANOVA for those that are measures over time. You have measured for different times, for different groups over time. For example, you measure different data from one group at so time, then after so time, like for example, at baseline, then after 1 week, after 2 weeks, after 4 weeks, after 6 months, after 3 months, after 6 months. You see, you have measured from the same group, but at different points in time, not more than, you have measured the data at different time, more than 3 times, 3 or more. So in that case, you are going to do repeated major ANOVA. But if it is only 2 times, you use independent sample t-test or paired sample t-test. So these are the common parametric tests. Another one is linear regression. When you want to do a regression, linear regression is a common parametric test. Then Pearson's correlation coefficient. If you want to measure a correlation between 2 continuous variables, you use Pearson's correlation coefficient. So these are the advantages and disadvantages. Then non-parametric tests. For non-parametric tests, they are called distribution-free tests. It means once you run the distribution of the data and you find out that this data is not normally distributed, then you are going to consider non-parametric tests. They are suitable for nominal data, usually, nominal or categorical data. We said the parametric tests, they are suitable for continuous data, but non-parametric, they are suitable for ordinal and nominal data. They are used when data are skewed or data is having an outlier or when the sample size is too small. So if the sample size is too small, they are also used as against when the sample size is too large, where we say we can apply the central limit theorem and assume that that data is normally distributed. So it usually compares median, not means. If you are using non-parametric tests, you are not using, you don't compare means, rather you compare medians and range, not mean and standard deviation. So that is for non-parametric tests. So some of these non-parametric tests include Mann-Whitney U-test. This is a non-parametric alternative of independent sample t-test. It compares median between 2 independent groups, as independent sample t-test does for means if you are using parametric tests. Then we have Wilcoxon Sign Rank test. This is a non-parametric alternative of paired sample t-test. It compares 2 related samples. Then we have Kroskal-Wallis H test. This is a non-parametric alternative of one-way analysis of variance, one-way ANOVA. It compares more than 2 independent groups. Then we have Friedman's test. Friedman's test is a non-parametric alternative to repeated major ANOVA. It compares repeated major across multiple groups. Then we have chi-square test. This chi-square test is used for categorical data to test the association between 2 variables. So for chi-square, whether your data is parametric or non-parametric, provided if it is categorical data, then you are going to use chi-square test. So in some people are categorizing, are putting it as a parametric, while some are putting it as non-parametric. But whatever, even if you have a parametric, normally distributed data or not normally distributed data, you are still going to use chi-square for independent, for categorical variables. Then Spearman's rank correlation coefficient. This is a measure that, this measures the strength and direction of association between 2 rank variables. Then we have sign test. Sign test is very simple test to compare the median of paired differences. So there are advantages and disadvantages, and we have here the differences between parametric and non-parametric test. This is the parametric test and their non-parametric equivalents. I will give you the data, so that's why I'm rushing. I just want to reach to the level of the analysis. That's why I'm rushing this one. So when to use each test, I have already written them. When to use this, when to use this. So you use non-parametric tests when what? Data are not normally distributed, sample size is small, data are ordinal or nominal, variances are unequal across groups. So now let's go to statistic analysis proper. This one, I will show you how to do them one after the other. So you see, for one test, one sample t-test, we said one sample t-test, this is the data requirement for this test. If your data meet these requirements, then you can use one sample t-test. Number one, data must, the test variable that is continuous, test variable must be a continuous variable. So it must be taking the variable that you are going to do this one sample t-test must be a continuous variable. That is, must have been taken in numbers, not in categories. Number two, scores on the test variable are independent. So the test variable, your test variable, you have independence of observation. Each observation is independent of other observation. Number three, random sample data from the population. You have taken your data randomly from the population. Number four, normally distributed data. Number five, homogeneity of variance. Number six, no outliers. Number six, no outliers. So these are the requirements for independent sample t-test. How do you run it? You go to analyze. I have written everything here. Analyze, compare means one sample t-test. So when you see, this is what you will see. When you click on analyze, compare means, and one sample t-test, this is what you will see. And once you see this, you now go to the one sample t-test window opens where you will specify the variables to be used in the analysis. So you see, when you open your SPSS, as you follow this, these directives, this is what you will see. So you select your variable that you want to do a one sample t-test with. When you select it, you take it into the test variable here, which is A. Then the test value, you enter the test value here, then you continue. So move the test variable. Everything is written. You just follow it as it is. Just follow it. I have described everything, even the output, the result that you will see. I have described everything here. So this is decision and conclusion, how to make a decision and how to conclude for after the test, after your analysis. The next one is independent sample t-test. For independent sample t-test, these are the requirements. So these are the requirements also. So now from the SPSS, if you want to run independent sample t-test, you click on analyze, compare means, independent sample t-test. You now follow all the things, all the directives that I have written here. So you follow them, and even the output, your result, this is how your result will show, and I have written everything there. So that is independent sample t-test. Then for paired t-test, I've also done the paired t-test. I've done it and explained everything. Then one-way analysis of variance as well also, I've done it. Pearson's correlation, I've done it. Pearson's correlation. So that is for parametric test. Then non-parametric test, like chi-square test of association, there are some assumptions for chi-square test. Number one, your two variables should be measured at an ordinal or nominal level, that is in categorical value. Then your two variables should consist of two or more categorical or independent groups. So this is how to run the chi-square test, click on Analyze, Descriptive, Crosstabs. Then step 2, you will be presented with the following crosstab dialog box. Step 3, transfer one of the variable into the rows and another variable into the columns. Then just follow it. I am very sure once you follow it, you will find it very easy. So that is chi-square. We have done parametric tests and non-parametric tests. For non-parametric tests, we have only done the commonest, which is chi-square test. So for correlation also, we have I have the data for correlation. I think this is the okay, I think the correlation lecture is not here. So let me quickly go to data presentation using tables and figures. So you see this this presentation or this lecture, there are many things in it. That is why I'm rushing it, because all these things are very important also. But I make the lecture easier for you. When I share with you the presentation slides, you will find it easier in the analysis. I think you can be using these slides to analyze, to practice some of the, to practice data analysis using for these different types of test statistics that we have mentioned. So the next one now is data presentation. Data presentation, now you have finished your analysis, everything is, you are through with your analysis. The next thing that you are going to do is what? To present your data in tables and figures. So that is data presentation. We want to present our data. So data presentation can be in four forms. It can be in 4 forms. It can be either, data can be presented either textually using text, or using tables, or graphs, or maps. So there are 4 forms of presenting data, but usually for our part 2 works, we usually use 3. That is textual presentation, tabular presentation, and graphical presentation. But let's look at all of them and see. So for textual presentation, this involves describing data and findings using written or spoken words. It is often used to explain the context, highlight key statistics, or summarize important findings when numerical or graphical presentation alone may not be sufficient. For example, you can say out of the 500 respondents, 62% were female and 38% were male. The average age was 35.4 years with a standard deviation of 8.2 years. So you see, this is a textual presentation of data. So even if you have your tables and figures, you still follow them with a textual presentation by narrating your tables and figures. So this textual presentation is usually done for after every data presentation, whether it is in table or it is in figures, or even if it is in map. You have to also follow it with a textual presentation by narrating your figures or tables. So now next one is tabular presentation. Tabular presentation is the most common method of displaying data. It usually forms the basis for the other forms of data presentation. Data is organized in rows and columns and allows precise comparison and compact display of large data sets. It's used for the demographic tables, statistical summaries, and cross-tabulations. It requires clear titles, labels, and footnotes for interpretation. So any table that you want to create, that table must have a title, it must have a label, it must have a footnote for interpretation. That is where you will now, if in footnote, you will now interpret what is in the table. So let's look at the example. These are the general principles of designing a table. Number one, clarity and simplicity. The table should be easy to read and interpret. It should avoid overcrowding. Avoid overcrowding with too much information in a single table. Use consistent formatting. If you are using font size 12, it should be consistent. All the tables should have font size of 12. If you are using alignment, left alignment or right alignment, whatever types of alignment, it should be consistent. If you are using single spacing or double spacing, you should be consistent. Then title. You must provide a clear, concise, and descriptive title above the table. So the title of the table should always be above, not below. If you are writing the title of the table, it should be above the table. That is table 1. So, table 1, socio-demographic characteristic of the study participant. Table 2, this. Table 3, age distribution of HIV patient in Sokoto. So that is how you are going to be writing it. It should be above the table, not below the table. Then logical structure. Organize the data in a logical order to follow an alphabetical or by magnitude. If you are using, for example, age group, you start with the age group that is having the highest frequency or highest percentage, or the frequency or the group that is having alphabet that follows alphabetical order is better. For example, maybe you have Hausa, Igbo, Yoruba in your tribe. Hausa, Igbo, and Yoruba. So which of the tribe follows first? H is number 1 before I. So you see Hausa first, then Igbo, then Yoruba in that order. You can also choose to use the tribe with the highest frequency and percentage. You start with it, followed by the next one that follows it, then followed by the least tribe. So you can choose any chronological order, either alphabetically or by magnitude. You can choose to, but don't put your categories anyhow. The first one is here, then you see the first category maybe is the one that's having the least frequency, or is the one that is having the Z. So it's not like that. That is better to present it in a logical structure. Then place related variables in adjacent columns or rows. So all the related variables should be in adjacent row or in adjacent column. It's better for you it's better than writing them scatteredly without any logic. Then group and label similar categories clearly. Clear labels. All columns and rows must be clearly labeled. You have to label your row, you have to label your columns. You have to give them a very descriptive names or descriptive labels so that anyone that sees them will understand what you mean. Use full terms or provide footnotes for abbreviations. So you can either write the full name of each word without abbreviating, but if you choose to abbreviate, you have to have a footnote where you explain your abbreviations. You define all your abbreviations in the table. Then include unit of measurements. For example, if it is age, you have to put in years. If it is weight, in kilogram, height, in meters, like that. Percentages, put percentages above, so that anybody that see this table will recognize everything, will understand everything without asking questions. Then headings and subheadings. Use columns and rows headings to indicate the content of each section. Subheadings can help break down complex data into understandable parts. Use of footnotes. Provide explanation for symbols, abbreviations, and all usual findings using footnotes. Indicate the source of data if it is a secondary data in your footnotes. Then appropriate use of decimal places. You have to be consistent in the number of decimal places that you are using. For example, if you are using 2 decimal places, it should be consistent. If you are using only 1 decimal place, you should be consistent in all the variables. But you should not be using two decimal places in this variable and then go to another variable and use 3 different decimal places and go to another variable and use only 1 decimal place. So that one is not precise, it's not appropriate. Then avoid redundancy. Do not repeat the same data in multiple parts of the table. Exclude irrelevant or unused variables. So these are the properties or the general principle in designing a table. So once you are designing your table, you have to follow this principle in order to make your table very good and clean. So let's see the example. This is the example of a table. You see the title of the table is above. Table 1, age and sex distribution of HIV patients attending ART clinic in Sokoto, 2024. Our N is equal to 300. That is, our sample size is equal to 300. So you see, we have labeled all our columns and rows. Column number 1 is age group in bracket in years. You see, you have to put your what? You have to put all the you have to put, if it is years, you have to put years. If it is weight, you have to put kilogram. If it is height, you have to put meter. So then the next variable is male. You see male, they are 120, while female, they are 180, then total 300. You see for the rows, we have row number 1, 15 to 24, 25 to 34, 35 to 44, and up to the end. So this is the example of table, simple table. Another example, you see another frequency table, frequency and percentage. You see, you have to define all your variables, duration of diagnosis with hypertension, 3 to 6 months, more than 6 months, number of antihypertensive taken daily, 1, 2, more than 2, family history of hypertension, yes, no, cigarette smoking, yes, no. So you see, frequency is here, percentage is here. This is the clinical characteristics of diabetic patients attending GOPC clinic in UDUTH, Sokoto 2024. Another example of a table, this table is comparing 3 groups or 3 categories. You see, it's a chi-square table, is comparing level of PSS and medication adherence. So PSS is what? Is perceived spousal social support and medical adherence among diabetic patients attending GOPC clinic. So we have good, moderate, and poor. Then we have for the medication adherence, then for the level of PSSS, we have strong, moderate, and poor. You see at the footnote, I have written PSSS, perceived spousal social support. So I have defined my footnotes. I have defined all my abbreviations. And then chi-square, x-square here is equal to Pearson's chi-square test. So that is what you do in your table. This is another table. It's a complex, a little bit more complex table than the other ones. So these are all examples of tables. So let's look at the graphical presentation. So graphical presentation, these are visual presentations. They are visual representation of data using charts and diagrams. There are different common types of charts, which include bar charts, pie charts, histograms, line graphs, box plots, scatter plots. So bar chart is done for comparing categories, while pie chart is for showing proportions. Histogram is for frequency distribution of continuous data. Line graph is to show trends over time. Box plot is for data that is distribution, for data distribution and outliers. Then scatter plots is for relationship between variables. Let's look at the principles for designing a chart. So designing a clear, accurate, and effective chart for data presentation is crucial in public health for communicating findings to diverse audience from policymakers to researchers. Below are the key principles to follow in designing any chart, either bar chart, pie chart, or line graph. Clarity. The chart should communicate its message at a glance. Once you look at it, you should be able to find out, you should be able to understand what the chart is saying. It should be labeled clearly, all the axes and the series of all categories. Then accuracy. Ensure that the chart faithfully represents the data. Use appropriate scales. Start y-axis at 0 for bar charts to avoid distortion. So these are all the, descriptive title. The title should mention key variables, population, and time frame if relevant. In academic writing, that is during research reports or project or thesis, place the chart title below the chart. While in presentations or community reports or training materials, you can present the title above the chart. So now for researchers, the title of the chart should be below the chart, not above the chart. As we have said, in table we say the title of the table should be above the table. But for chart, the title of the chart should be below the chart. for research reports. Then labeling. All these are the principles. And let's look at bar charts. Bar chart is a graphical tool used to represent a categorical data using rectangular bars. So bar chart is done for categorical variables, not for continuous variables. When you read these properties, you see everything about bar charts. You see everything about bar charts. Types of bar charts, we have simple bar chart, compound bar charts, and component bar charts. I have described all of them. This is simple bar chart. You see, each bar is representing one, that is figure 1, number of respondents recruited by divisions. So you see, each bar is showing us the division of the respondents. Idikoago, Homu, Otu, Ago-Ade, Aboho, or Eboho. Then this is simple bar chart. This is simple bar chart also presenting the two categories, like you see the figure, the name of the figure is below the figure. That is blood pressure control status of diabetes patients in Sokoto 2024. You see control, those that have controlled blood pressure and those whose blood pressure is not controlled. That is another example for it. Then this is another simple bar chart. Figure 2, level of perceived spousal social support among diabetic patients in Sokoto 2024. You will see different bars. The one, number 1 is strong support, moderate support, and poor support with their frequencies and percentages. So now compound bar charts. Compound bar chart also, you see it, like this is the population and land area by region, Asia, Europe, Africa, Latin. One of the bar is population, and then the other bar is land. So you see population and land for Asia, population and land for Europe, population and land for Africa. That is your multiple bar chart. Then component bar chart. Component bar chart is also explained here. See, this is how to present a component bar chart. You see, in one bar, you represent 3 or more than one group. You see, male and female are presented or are presented at different census decades. During census, this one is 1903, 1913, 1923, 1933, 1943, and 1953. This is the growth of a population from 1903 to 1953. Then the next chart is pie chart. Pie chart is a circular chart that divided into sectors, where each sector or a slice represents a proportion or percentage of a whole. It has the following properties. 1, the entire cycle is equal to 100%. Each sector represents a category's contribution to the total. The angle of each sector, that is category value, is divided by total value times 360 degrees Celsius centigrade. Then best used when you have less than 6 to 7 categories. So if you want to use pie chart, you should not use pie chart for when you have 6 to 7 categories. Your pie chart should be used when the categories are less than 6. That is when you have either 2 categories, 3 categories, 4 categories, 5 categories. But you can use bar charts for more than 6 categories, from 6 to above. But bar chart can also be used if categories are less than 6 also. So these are the principles of pie chart design. Principles of pie chart design. This is the example of pie chart. This one has 3 categories: poor adherence, moderate adherence, good adherence. The Figure 3 level of medication adherence among diabetes patients in Sokoto. Then next one is histogram. So I think you go and read histogram, just go and read everything. Everything is self-explanatory. I'm very sure if you read them, you will understand all of them. Line graph. These are the properties of line graphs. Map. Then this is map presentation. Dot density or spot map. Yeah, I think that is all about data presentation for me. Then the next thing in brief, let's just briefly discuss how to defend a dissertation. This one, I have not made any slides for it. I think we can just briefly discuss it. So if you want to defend your dissertation, when you come for defense, the first thing you must come with the template of your book. You have to have a template of your book or a copy of your book that you are going to defend. And before coming, you must understand everything from the book, especially your specific objectives. Your specific objective must be at the fingertip of your at your fingertip. Then your justification of the study or rationale of the study. The problem that you think that makes you come up with the topic, you must know it before coming for the defense. So you must know your problem, the justification, specific objectives, and most importantly, your methodology. So in methodology, you must know everything in methodology before you go for dissertation defense. Because most of the discussion that you are going to do is from the methodology. Almost 80% of your discussion with the examiners will be in methodology. So you have to know your methodology in and out, so that, because once you don't know how to do, how you have done something, or you don't know how you're supposed to do it and you did it wrongly, once you fail methodology, most likely you are failing your book. Because if you fail a methodology, it means you have to change that. You have to go back to what? You have to go back to the field. So once you are going back to the field, you know you are going to repeat the exam. Once they say you should go back to the field, and mostly you go back to the field if your methodology is wrong. If one of the methodology is wrong, you are most likely going to go back to the field. And once they say you go back to the field, it means you are repeating the exam. So these are the tips that you will put in your mind. Know your objectives first. The problems that makes you come up with this topic, know it. Then the justification of this research. Then the methodology. You must know the methodology in and out. Whatever you are being asked from your methodology, you must be able to explain it very well. So if you can explain everything from your methodology, then I don't think you will fail that defense. Another thing, don't ever argue with an examiner. Because even if you think what the examiner is saying is wrong, don't argue with him, just accept it. But in your mind, you know it is wrong. because there are many examiners that are insisting on a wrong idea. They are insisting on a wrong idea, but if you argue with them, they will fail you. They think they are right, even though they are not right. But even if you know that they are wrong, just accept that they are right, so that you pass your exam and go. Because if you start arguing, even if at the end of the day they find out that they were not correct, they are likely to penalize you. So just accept what they are saying. And another thing, if you are asked anything, why have you done this? Why have you done that? Don't relate that your activities or your work to any of the examiners or any of the assessor. Don't say, no, I have done it because my assessor or my supervisor say I should do it. No, don't relate anything to your supervisor. Everything is your own now. You should make sure that you have defended all what you have done. Don't relate it to your examiner. Don't to your supervisor or to your assessor. Your assessor, even if he's at the point of exam, he may reject you. So don't relate anything to the assessor. Just take it as your own and accept it. Even if it is wrong, accept it and tell them that you are going to correct it. Mostly, if you have done something you have done something wrongly and you have already submitted your book with that wrong submission, the best thing is to correct it before going for exam and go with it. Go with the corrected copy with you. If they ask you, why did you do that? Why did you do this? You can say, no, sir, after I submitted the book, I later found that it was wrong. And since I have already submitted, I now corrected it and I come with it now. And with it, I can present it so that you can now open it and present it to them. They can say, okay, let's see whether you have corrected it or not. Then if you show them, they will say, yes, you are correct, you are right. But if you didn't do that, they will think you are not, even if you have corrected it, but you didn't come with it, they will not agree with you and they may penalize you. That is another tip. Then before you go, you have to summarize your book. You can make a 3 form of summaries. You may summarize it in 5 minutes, in 10 minutes, and in 15 minutes, because you are likely to do one of these summaries. Once you come, they will ask you to summarize your book. Some examiners will say summarize your book in 5 minutes. Some will say in 10 minutes, and some will say in 15 minutes. And some will not even specify the time. They will just say summarize your book. So when you come for summary, the first thing that you do, tell them the title of your work. The title of my work is so. This work was done among so people in so place with the following objectives. Then you now state all your specific objectives. So now when you finish with this, you now briefly provide a brief background of the study, then brief problem statement, just in maybe 1 or 2 sentences, then justification of the study. After that, then you go to the methodology. You now go to the methodology, summarize your methodology. After summarizing your methodology, then you go to what? You go to results. So results, you summarize the result according to objectives. Don't summarize, don't say all the results. No, just pick each and every objective and summarize the result for that objective. You said, for example, your first objective is to find out, to assess the prevalence of malaria among healthcare workers. Just say, my results show that the prevalence of malaria among the primary healthcare workers was 30%. That's all for that objective. Then go to summarize another next objective, then next objective. That's all. When you finish with the objectives, then you conclude, make a brief conclusion, and then a recommendation. So this is how you follow your discussion. Then you have to also know, because some examiners may ask you, how will your study contribute to the knowledge? So you have to now know, how will my study will my study contribute to the overall knowledge, or to the knowledge field, to the field of knowledge? So you see, you can now design it yourself before you go for exam. You make sure that for each objective, each and every objective of your study will contribute to a particular knowledge, will provide a particular knowledge. So you now go and find out, for this objective, how will this objective contribute to the knowledge? How will this objective contribute to the knowledge? How will this objective? That is how you now have many things to say. But if you only say one thing, then you will be short. But just use your objective to make sure that each objective will contribute to the knowledge, to the field of the knowledge. That is for that. So I think, in brief, this is the briefly how to defend your dissertation during exam. Thank you very much, and thank you for listening. And I think we now entertain, whether are we going to entertain question and comment, because I think the time now is past almost 6:30. I don't know whether we entertain question. If we are going to entertain question, maybe a few questions, then we call it a day. Thank you very much.
Okay, thank you so much, sir, for the elaborate lecture. Thank you so much. This is highly practical. Really appreciate it, sir. So entertain questions and comments. Like our teacher said, it should be brief. So if anyone has any question, you can drop it on the chat box, or you can indicate by raising your hand, so we allow you to talk. I have one question here on the chat box. This person is saying, Dr. Anichi is saying, please, what are outliers? What are co-founder? Thank you, sir.
Maybe you have not been following us in the previous sections. We have defined all those things, outliers and confounders. So I think, can we explain them now? We have been explaining them before. So outliers, yes. When we say an outlier is a data that you have gotten, which is far different from the usual, from most of the data. Maybe 90% of the data are, for example, you want to find the age group of a particular class. The age group, the ages of the particular class. You see, most of the students in that class, they're having their age within the range of 20 to 25. But you find another person who is 50 years old. So that person is an outlier. He is not within the range of most of the people in that sample. So he is an outlier. Another example is, you are dealing with adults. Maybe your sample, most of the people in your sample are within the age range of 30 to 40. But you now see another person in that sample whose age is 2 years. So you see, it's an outlier. He is totally different from the ages of other people, most of the people. That is an outlier. Then a confounder. A confounder is a variable or is a characteristic that that can affect or that can change the result from its true from the true result, from its actual value. For example, this result supposed to be you're supposed to reject the null hypothesis, but because of a confounder that confounded that result, you now say you are not going to reject it. Let me give you an example. You are studying a cancer. You want to find out whether cigarette smoking can cause lung cancer. So now, you now select your sample. All the people you selected, they are 70 years and above. So now, at the end of your results, you find out that you now reported that cigarette smoking is definitely causing lung cancer. But you don't know that that lung cancer you are seeing, that relationship that you are seeing is not due to cigarette smoking, but is due to age. Because most of the people, they are 70, all your sample, they are 70 years and above. So even their age alone, even if they are not smoking cigarettes, their age alone can make them have lung cancer. So in this case, because you don't even know that age can cause lung cancer, you just conclude that this cigarette smoking is causing lung cancer. But without you knowing that this difference that you are seeing is due to their age, not due to cigarette smoking. So in that case, age is a confounder. It confounded your result. Your result that you are seeing was not due to cigarette smoking, but due to age. Because you have not measured age, you have not measured whether the age can cause lung cancer. You only measure whether cigarette smoking can cause lung cancer. That is why you are seeing this result. And this result is not due to cigarette smoking, rather is due to age. Therefore, age is a confounder. So that is the difference. That is what is confounder and then what is outlier. I hope you understand that. Thank you.
Okay, thank you so much, sir. This is elaborate. Thank you. Others that we have our compliments. Dr. Bliamin Omar is saying thank you so much, sir. Dr. Henry, thank you, sir. Very insightful. Dr. Uche is saying thank you, sir. So all other ones are compliments. I saw Dr. Karen raising hand. Dr. Karen, can you unmute and talk?
Okay. Good evening, sir. Thank you very much for this great sacrifice, taking us sacrificing your time. We appreciate you, sir. Sir, please, I want to ask if at the proposal level, someone did a study design, he wrote observational cross-sectional study. He did I did a diagnostic validation. So now after attending these classes, now I've now understand that it's vague because observational has both analytical and descriptive. So is it right for me to still send it back, as in at my dissertation level, I should still write observational cross-sectional study, or I should write the proper thing, because my work involves also comparing some other continuous variables. So
okay,
somebody was advising that it will be is like a cross-sectional diagnostic study. But if after attending these classes, I now saw that if I change it to cross-sectional diagnostic, the formula, sample size formula may have to change. If I say, okay, let me use analytical cross-sectional, the sample size too will differ, and then it will become more complicated. So I'm on the fence now. Where should I go? That's one question that I have.
Okay.
Then,
So you see, study designs, generally they are classified into two: observational and experimental. So any cross-sectional is observational. Any cross-sectional study is an observational. The mistake that we are making is to say descriptive cross-sectional, or most of us say descriptive cross-sectional when they are not using only descriptive, they are using analytic. They now say descriptive cross-sectional. So what I advise you is that just leave it as cross-sectional. Don't add anything. This is a cross-sectional study. That's all. So don't say,
okay,
don't make any, don't give any addition. Just this is a this is a cross-sectional study. You didn't describe whether it is a descriptive, whether it is a analytic, whether it is observational or whatever. Just mention it is a cross-sectional study design. This study used a cross-sectional study design. That's all. So I don't think your own is, there is no problem. Since you said observational. Observational, usually all the cross-sectionals are observational studies. So there is no cross-sectional that is experimental study. So all the cross-sectional studies are observational, but for subsequent use, you can be using cross-sectional study without qualifying it. Thank you.
Thank you so much, sir. Thank you so much, sir.
Yes.
Further compliment, thank you, sir, for these detailed lectures, and thank you, UDUTH, for this workshop. Thank you all. Thank you very much for the informative, insightful, and educative presentation. This very in-depth, sir. Thank you, the organizer, UDUTH, and the resource person, Dr. Malami. Thank you so much, sir. So many compliments. We cannot read all.
Yes.
Thank you so much. We really appreciate your efforts. May Allah reward you abundantly. The other organizers, the Education and Research Committee, thank you so much for the effort. Thank you, Chief Abdulkadir Katago, our ICT person, for all you do. Thank you so much, sir. Before we round up this session, I would like to call on the President of ARD UDUTH, Dr. Murtala Bello Ibrahim, to give us a short closing remark. Mr. President, hope you are close by.
Thank you, Dr. Mujitaba, for the job well done. On behalf of the Supreme Congress of ARD UDUTH, I would like to express our deepest appreciation to the presenters, more so in person of Dr. Malami. Sir, we thank you very much for your effort, your sacrifice, and the job well done. We also like to thank Dr. Asma Uwali and Prof. Habibullah for carrying us along this tiring time, this series of lectures over the past 6 to 8 weeks, for almost 2 months consecutively. We really appreciate you, sir. We cannot repay you. We can only pray for Almighty Allah to continue to bless you, to bless your family, to bless your effort, and the best reward in the hereafter. We also like to thank the Education and Research, Scientific and Research Committee of ARD UDUTH, spearheaded by our able Vice President in person of Dr. Mujitaba, as well as our listeners and participants in this lecture series. I appreciate you all. Although I have not been able to be gracing the program every time, as I have been engaged in other activities, but from what I have been receiving, the program has become an international program. We receive accolades from our neighboring countries like Ghana, Sierra Leone, and the Gambia, all of whom have really showed their appreciation. I think so far is one of the best research and methodology program that we have had in a while ago all over the country. So we appreciate you all, and we pray for Almighty Allah to bless the knowledge that we have gathered and make it beneficial to us in both our exams and our future endeavors. Thank you all once again. Over to Dr. Mujib Saba and Dr. Madami. I appreciate you well. Thank you.
Thank you so much, Mr. President. Thank you so much. You have done very well. We have been whining on your wheel. Thank you so much for the participation. Thank you all. We so much appreciate your patience and your follow-up. This brings us to the end of the program. We so much appreciate you. We pray many of this program should come either from ARD UDUTH, from any other association. Education is always the key, and information is a door to any success. Thank you so much. I think with this, we have come to the end of this session. We'll see you again. The recordings and the slides will be made available, God willing. I think if not in all the groups, but in the ARD UDUTH research methodology group. Thank you all for joining. I'll see you next time.
Thank you very much, sir.
Thank you very much, sir. It's a wonderful.
Inshallah, we'll look forward to the next next series of the lectures with within after some months, inshallah.
Okay, thank you so much, sir. Thank you. I saw you leaving earlier. Thank you. You're back.
Yes.
Like what Mr. President said after you left, this series has become an international series. In fact, people are calling from Ghana, from most of the African countries to appreciate the efforts.
Yes.
Thank you so much, sir. Thank you, sir.
Not just that. Professors, they download this series and watch.
Hey.
Professors. Yes, sir.
Yes.